I'm sorry?
Q2.
Yeah, column vector 2, 5, right? So it's pretty clear. Okay, here's definition of linear independence, right? There it is. Now here's a set, and we want to test for linear independence, right?
Right.
So what do? Well, here's a set of vectors, right? I guess we might call this V1, V2, and V3, and that fits right into our... Okay, well, clearly then, V1 is 2, 5, V2 is probably unnecessary for me to write this out, but let's just be sure. 3, 4, and V3 is 1, 6. Now, we have an equation, right? Even if we don't understand everything that it says about this equation, we can write down the equation, right? And then see if there's something we could do with it.
Mm-hmm.
And then maybe then, whenever we do whatever we think we can do with it, fit it into the entire statement, right? So if nothing else, we can at least start by writing out this, which would be C1 times 2, 5 plus C2 times 3, 4 plus C3 times 1, 6 equals the 0 vector, which would be 0, 0, right? Now, does that look like anything you saw on the major quiz? Okay? One of the reasons why it was there is because it's here, but also because we talked a lot about it, okay? And not everybody did everything they should have with that one, although some people did okay with it. Okay, so what do we do with this equation? Well, we've got an equation. Do we have any unknowns? C1, C2, and C3 are unknown, aren't they?
Mm-hmm.
Well, would it make sense to try to solve this equation? Okay? So, okay, well, how do we solve the equation?
Set it up as an augmented matrix.
Again,
Set it up as an augmented matrix.
we could set it up as an augmented matrix. Ultimately, everything is a system of equations. So I'm going to recommend that you always, if you aren't sure what to do, go back to the system. Okay? So this is a system. The left-hand side can be written well, just using the fact that C1 times 2, 5 is 2C1, 5C1, right?
Mm-hmm.
And I'm going back to a lot of detail that I'm not sure everybody has, although I'm sure most of you probably do. Again, I haven't looked at everybody's test. But judging from some of the errors I saw, they're just fundamental things I'm not sure that we really are thinking about. I think most people understand them. And I said the left-hand side, I'm going to say the equation can be written because I don't want to have to rewrite it with the right-hand side. The equation can be written like this, right? And how else could it be written then? Well, can I simplify the left-hand side some way?
Take it out of the brackets and split it into two equations.
Well, I got a vector plus a vector plus a vector. I can add the first element and add the second element on through, right? So that gives me 2C1 plus 3C2 plus C3, 5C2 plus 4C2 plus 6C3, equals 0, 0, right? And then what? Well, now that I have, now I have this, I can say, okay, now 2C1 plus 3C2 plus C3 equals 0. 5C2, C1 plus 4C2 plus 6C3 equals 0. Okay? So this equation here translates in this specific case to this, which translates to this, which translates to this, which gets us to a system, which is where we started the course. Now what can I do with that system? Well, the first thing we did was we reduced it. We could reduce it just as it is, right?
Mm-hmm.
We could reduce, but that's equivalent to what we do with the augmented matrix, which is, of course, the first suggestion we got out of the class. I don't want you to go directly from this to an augmented matrix. Now, if you write down the correct augmented matrix, okay, but if you just do it out of habit without thinking, well, let's see, this is going to do this, this, and this, you can pretty much think through that in your head and get to the augmented matrix. But if you don't think through those steps, you're going to lose track of them. And I see evidence so far on the test that there are things people lost track of because you started doing things automatically without thinking it through. Okay? There's time on the test to think everything through. And this is what I mean by thinking it through. All the connections. Otherwise, you miss things. And everybody that I've seen so far missed something really obvious by not doing it. Okay? So, we go to the augmented matrix, and of course we know what the augmented matrix looks like and why it is what it is, because it just works on the numbers, knowing that each column represents a different variable, right? So we know the connection between this and this, the connection between the row operations and the process of eliminating variables. And it's not something we do out of habit without thinking about what it means, okay? Does that make sense? Okay, now we reduce, right? I'm not going to go through the details of reducing this, because I'll probably screw it up if I haven't already screwed something up. Okay? You know, use one of the coefficients for the subscript or something, you know, I'm prone to do it. I don't think I've ever done that. But you notice I got one of the subscripts wrong here because I was about to write a 2 in this one, right?
Mm-hmm.
Thinking ahead. Okay? So keep an eye on me, as I always say. Okay, now. Okay, this reduces. Can you give me a clue what form we expect this will probably reduce to? What are the possible forms?